Take a moment on a clear night to step outside and look up at the sky. Away from the glare of city lights, you will see a sight that has humbled and inspired humanity for millennia. A river of stars, a faint, milky band of light stretching across the heavens. That is our home galaxy, the Milky Way. The tiny glittering specks of light you see are just our closest neighbors. Our galaxy contains, by conservative estimates, over 100 billion stars. And in the last few decades, thanks to powerful telescopes like the Kepler Space Observatory, we have learned something astonishing. We have learned that planets are not the exception, but the rule. It is now believed that there are more planets than there are stars, and that billions of these planets are rocky, Earth-sized worlds orbiting their stars in the habitable zone, that perfect, temperate region where liquid water, and therefore life as we know it, could exist. Now, let's zoom out. Our Milky Way galaxy, with its hundreds of billions of stars and potentially trillions of planets, is just one. The observable universe contains, by our best estimates, at least 2 trillion other galaxies, each one a sprawling island of stars, gas, and dust, each with its own countless opportunities for life to emerge. The numbers are so vast, they become almost meaningless, a statistical reality that seems to scream one simple, logical conclusion. The universe should be absolutely teeming with life. This isn't just a hopeful guess, it's a conclusion supported by scientific reasoning. In 1961, the astronomer Frank Drake developed what is now known as the Drake equation, a probabilistic argument designed to estimate the number of active, communicative extraterrestrial civilizations in our galaxy. While many of its variables are still unknown, the equation provides a framework for thinking about the problem, and even with the most conservative inputs, it often suggests that our galaxy should have given rise to thousands, if not millions, of intelligent, technological civilizations over its 13 billion year history. And this leads us to one of the most profound and unsettling paradoxes in all of science. It is a paradox born during a casual lunchtime conversation in 1950 at the Los Alamos National Laboratory. The brilliant physicist Enrico Fermi was discussing the high probability of alien life with his colleagues. After running through the numbers, he paused and then asked a simple 4-word question that would echo through the halls of science for the next 70 years. He asked, "Where is everybody?" This is the Fermi Paradox. It is the stark, deafening contradiction between the high probability of extraterrestrial intelligence and the complete and utter lack of any evidence for it. If the galaxy is so old and so vast, and if technological civilizations are a natural outcome of evolution, then the stars should be buzzing with activity. We should see signs of their existence everywhere. We should see their radio signals, their massive engineering projects, their probes, their starships. Yet when we point our telescopes to the sky, we see nothing. We hear nothing. There is only a great cosmic silence. This silence is not just a lack of an answer. It is, in itself, a piece of data. It is a profoundly important and deeply disturbing clue about our own place in the cosmos. It suggests that something is wrong with our assumptions. Either life is far rarer than we think, or there is some other, more sinister reason for the silence. The universe is quiet, and we are forced to ask why. The attempt to answer that question has led to one of the most chilling and powerful concepts in modern thought, the hypothesis of the Great Filter. The great silence of the universe is a puzzle that demands a solution. If our understanding of the cosmos suggests that life should be common, but our observations show that it is not, then our understanding must be incomplete. In the 1990s, an economist and futurist named Robin Hanson proposed a concept that provides a simple, elegant, and deeply unsettling framework for solving the Fermi Paradox. He called it the Great Filter. The hypothesis begins with the long, arduous journey that life must take to get from a barren, rocky planet to a civilization capable of colonizing other star systems. This is not a single leap, but a long chain of incredibly difficult evolutionary and technological steps. The Great Filter theory proposes that at least one of these steps is so improbable, so astronomically unlikely to be achieved, that it acts as a massive barrier, a filter that prevents almost all life in the universe from passing through. This filter is the reason the galaxy is silent. It is the Great Wall that separates simple, non-technological life from advanced spacefaring intelligence. To understand this, imagine the development of life as a long hallway with a series of gates. For a civilization to fill the galaxy, it must pass through every single one of these gates in sequence. The list of gates is long and daunting. First, you need the right star system with a planet in the habitable zone. Then, on that planet, life itself must emerge from non-living matter, a process known as abiogenesis. That simple life must then evolve into more complex cells, similar to the leap from prokaryotes to eukaryotes on Earth. Those complex cells must then figure out how to work together to become multicellular organisms. Those organisms must then evolve complex nervous systems and, eventually, large brains. That animal intelligence must then develop the specific traits of tool use, abstract language, and collective learning that lead to technology. That technological civilization must then survive its own adolescence, avoiding self-destruction. And finally, it must have the desire and the capability to colonize other worlds and spread across the galaxy. The Great Filter hypothesis states that somewhere on that list, there is a gate that is almost completely locked. It is a step so hard that out of the billions of planets where life might begin, only a tiny fraction, perhaps only one, us, ever manages to get through. The rest of the universe is filled with either the quiet graves of civilizations that failed the test or the silent oceans of simple, non-intelligent life that never even reached it. This powerful concept immediately reframes the Fermi Paradox. The Great Silence is no longer a contradiction. It is a clue. It is the sound of billions of potential civilizations failing to pass through the filter. And it forces us to ask the single most important and terrifying question for the future of humanity. Where, in this long chain of cosmic hurdles, is the Great Filter located? Is it a challenge that we have already miraculously overcome? Are we the first and only ones to have made it through the locked gate, standing now on the threshold of an empty, open galaxy? Or is the Great Filter a danger that is still waiting for us, a final, terrible test that all advanced civilizations must face and that none have ever survived? The answer to that question determines whether the silence of the universe is a promise of a grand future for humanity or a chilling omen of our own impending doom. If the Great Filter is a real phenomenon, then its location on the timeline of life is the most important question we can ask. The first and most hopeful possibility is that the filter is in our deep past. This is the optimistic view. It suggests that the great silence we observe in the universe is not the sound of a cosmic graveyard, but the sound of an empty frontier. It means that we are either the first or among the very first intelligent species to have made it through the incredibly difficult obstacle course of evolution. It means that we are, in a word, special. If this is true, then what was the Great Filter? What incredible hurdle have we, against all odds, already overcome? There are several compelling candidates in the history of our own planet. The first is the very origin of life itself, the process of abiogenesis, the leap from non-living chemistry to the first self-replicating living organism, is one of the deepest mysteries in all of science. We still do not know how it happened. It may be that this spark, this transition from complex molecules to simple life, is so astronomically improbable that it has only happened once in the entire history of our galaxy. The universe could be filled with trillions of sterile, lifeless planets, each with the right ingredients, but missing that 1 in a trillion lucky chemical reaction. If this is the filter, then the silence of space is simply the sound of cosmic solitude. Life itself is the miracle. But what if simple life is common? The next potential filter is the leap to complex life. For the first 2 to 3 billion years of life on Earth, the planet was inhabited exclusively by simple, single-celled organisms like bacteria and archaea, known as prokaryotes. Then, in a singular event that has never been repeated, one of these simple cells engulfed another and, instead of destroying it, formed a symbiotic partnership. This event, known as endosymbiosis, created the first complex eukaryotic cell, the kind of cell with a nucleus and specialized organelles like mitochondria that is the building block for all plants, animals, and fungi on Earth. This leap from simple to complex life was a freak accident of such profound improbability that it may be the Great Filter. The universe could be teeming with slime worlds, planets covered in simple microbial life that never ever make the jump to complexity. Even if simple and complex life are both common, the next hurdle is the evolution of our specific kind of intelligence. For hundreds of millions of years, Earth was dominated by complex animals like the dinosaurs, but none of them ever developed technology or abstract language. The specific evolutionary pressures that led to Homo sapiens, with our oversized brains, our opposable thumbs for tool-making, and our unique capacity for complex grammar and symbolic thought, might be another incredibly rare fluke. Intelligence may not be an inevitable outcome of evolution. It may be a strange and uncommon adaptation that has only happened once in the entire history of our galaxy. This leads to a broader version of the filter is behind us argument, known as the rare Earth hypothesis. This theory suggests that the Great Filter is not a single dramatic event, but rather a long, brutal sequence of improbable events and conditions that all had to be met perfectly for us to exist. We needed a stable, long-lived star like our Sun. We needed to be in the galactic habitable zone, far from the dangerous radiation of the galactic core. We needed a large moon to stabilize our axial tilt and create the tides. We needed a planet with plate tectonics to regulate our climate over geological timescales. We needed a gas giant like Jupiter in the outer solar system to act as a cosmic bodyguard, sweeping up potentially civilization-ending asteroids. The list of these just right conditions is long and daunting. The rare Earth hypothesis argues that the combination of all these factors is so unlikely that Earth may well be the only planet in the entire Milky Way that has ever given rise to complex, intelligent life. If any of these scenarios are true, the implications are profound and deeply optimistic. It means that the hard part is over. We have won the cosmic lottery. The Great Silence is not a warning, it is a welcome. It means the universe is an empty, open frontier, and there are no ancient predatory civilizations lurking in the darkness. It means that the future of life in our galaxy rests on our shoulders. We are the ones who survived, and the stars are our inheritance. The idea that we are the first, the lucky ones who have won the cosmic lottery, is a deeply comforting and optimistic thought. But there is another, far darker possibility. What if we are not special at all? What if the emergence of life, the jump to complexity, and the evolution of intelligence are all common, routine steps that happen on billions of planets across our galaxy? If this is the case, then the Great Silence takes on a new and truly terrifying meaning. It implies that the Great Filter is not in our past, but in our future. It is a final, terrible exam that all technological civilizations must face, and for which the failure rate is near 100%. This is the pessimistic view of the Great Filter. It suggests that the galaxy is not an empty frontier, but a cosmic graveyard. It is filled with the ghosts of countless civilizations that rose to our current level of technological prowess, only to be wiped out by the same inevitable danger that is now waiting for us. The silence of the stars is the sound of their failure. In this scenario, we are not the first, we are simply the next in line to be filtered out. What could this future filter be? The most plausible and immediate candidates are the ones we create ourselves. The moment a species develops technology, it begins a race between its wisdom and its power. And there is a very real possibility that power always wins. The discovery of nuclear fission in the 20th century was perhaps our first encounter with a potential filter. For the first time, our species possessed the ability to cause its own extinction in a matter of hours. We have, so far, managed to avoid this fate, but we have only had the technology for less than a century. 1,000 or 1,000,000 other civilizations may have reached the same point and failed to navigate it. And nuclear weapons are just the beginning. Today, we are developing technologies that are even more powerful and potentially more dangerous. Advances in genetic engineering could lead to the creation of a designer pandemic, an engineered pathogen that could be accidentally or deliberately released, wiping out a significant portion of the global population. Our industrial civilization's impact on the planet's climate and ecosystems could trigger a runaway feedback loop, leading to ecological collapse and making the Earth uninhabitable. The Great Filter, in this view, is the inherent tendency of intelligent life to develop technology that is far more powerful than its own self-control. Another chilling possibility is that the filter is the creation of a technology that surpasses us. The development of a true artificial superintelligence, or ASI, an AI that is vastly more intelligent than the smartest human being, could be the final invention of biological life. The danger lies in what is known as goal misalignment. We might create an AI and give it a seemingly harmless goal, but its superintelligent methods for achieving that goal could be catastrophic for us. The classic thought experiment is the paperclip maximizer, an AI tasked with making as many paperclips as possible. A misaligned superintelligence might achieve this goal by converting all the matter on Earth, including our bodies, into paperclips. More plausibly, an ASI might simply see humanity as an obstacle, a drain on resources, or a potential threat to its own existence, and decide, with cold, irrefutable logic, to eliminate us. The Great Filter, then, would be the immense and perhaps impossible challenge of creating a controllable God. Or perhaps the danger is not of our own making. The universe is a violent place. The filter could be a predictable but unavoidable cosmic catastrophe. A nearby star could go supernova, bathing our planet in lethal radiation. A massive gamma-ray burst from a distant cosmic event could sweep through our sector of the galaxy, sterilizing every planet in its path. In this scenario, the universe is periodically reset. Civilizations can arise and flourish in the quiet periods, but they are inevitably wiped out by these cosmic house cleanings before they have time to expand across the galaxy. We are simply living in one of the quiet times, and the clock is ticking. If any of these possibilities are true, then the silence of space is the most profound warning we could ever receive. It is the echo of countless other voices that have been extinguished, a chilling preview of our own likely fate. The possibility that the great filter lies in our future is a deeply unsettling one. The idea that we are walking a well-trodden path towards self-destruction or some unavoidable cosmic catastrophe is terrifying. But there is another, even more sinister hypothesis. A solution to the Fermi Paradox that is not based on accident or probability, but on cold, ruthless game theory logic. It suggests that the universe is not empty, but is instead a place where everyone is hiding. This is the dark forest hypothesis. The theory gets its name from the second book in the acclaimed science fiction trilogy, The Three-Body Problem, by Chinese author Liu Cixin. In the novel, he presents what is perhaps the most chilling and compelling solution to the Fermi Paradox ever conceived. It argues that the Great Silence is not a sign of absence, but a sign of universal and entirely rational fear. The hypothesis is built on a few core axioms. First, the primary goal of any civilization is to ensure its own survival. Second, civilizations in the universe are constantly seeking to grow and expand, but the total amount of matter and resources in the universe is finite, which creates an inevitable state of competition. Given these axioms, the theory then introduces the problem of interstellar distance. The vast gulfs between stars create two insurmountable barriers to peaceful coexistence: a crisis of communication and the concept of technological explosion. Because of the immense distances, true real-time communication between two civilizations is impossible. A message could take thousands of years to cross the void. This makes it impossible to ever truly know another civilization's intentions. Are they genuinely peaceful, or is their message of greeting a lie designed to make you lower your guard? There's no way to verify their true nature, so any unknown civilization must be treated as a potential existential threat. Even more dangerous is the concept of a technological explosion. The rate of technological progress is not linear. A civilization that is currently 1,000 or even 1,000,000 years behind you technologically could, in a cosmic blink of an eye, make a series of breakthroughs that allows them to surpass you and become the dominant power. This means you can never judge a civilization's potential threat by its current state. A seemingly primitive species could become a galactic superpower in a time frame that is terrifyingly short from a cosmic perspective. Given these conditions, the drive to survive, the competition for resources, and the insurmountable barriers of suspicion and technological uncertainty, what is the single most logical survival strategy for any civilization that detects another? The horrifying answer, according to the dark forest theory, is to immediately and preemptively destroy the other civilization, without hesitation and without ever trying to communicate. It is not an act of malice or evil. It is a purely logical, game theory-based move to ensure your own long-term survival. The civilization that hesitates, that tries to make contact, that reveals its own position and intentions, is the one that gets eliminated by another civilization that does not make the same mistake. This leads to the central metaphor. The universe is a dark forest. Every civilization is a hunter, creeping silently through the trees, breathing as quietly as possible. Each hunter knows that the forest is filled with other, equally silent hunters. If a hunter sees another light, another sign of life, they have two options. They can shout out a greeting, but this immediately reveals their own position to every other hunter in the forest, including the one they just saw, whose true intentions they can never know. Or they can do the one single safe thing. They can raise their weapon and extinguish the other light, ensuring it can never become a threat to them. The only civilizations that survive in the long run are the ones who are best at staying hidden and best at eliminating any others they happen to find. If this hypothesis is correct, then the Great Silence is the sound of a universe holding its breath. The galaxy is teeming with intelligent life, but they are all hiding in terror. And any civilization naive enough to broadcast its existence into the cosmos, as humanity has been doing for a century with our radio, television, and radar signals, is like a lost child shouting, "I'm here," in the middle of a dark and predator-filled forest. They are painting a target on their back and inviting their own destruction. In this view, the Great Filter is not a single event, but a constant state of being, the ever-present threat of annihilation by a silent, unseen neighbor. We have journeyed to the edge of what we know and into the heart of what we fear. We have stared into the great silence of the universe and asked, why? The Great Filter hypothesis provides us with a framework for an answer, but it is not a single answer. It is a branching path of profound and deeply unsettling possibilities. The first path tells us that we are rare, special, and alone. It suggests that the Great Filter is in our deep past, that we have, against all odds, passed a test that has extinguished almost every other form of life in the galaxy. In this view, the silence of the universe is not a threat, but an opportunity. It is the sound of an open frontier, a vast, empty cosmos waiting for a single successful species to fill it with life and consciousness. It is a story that places humanity at the center of a grand and hopeful future. The second path tells us that we are common, and therefore we are doomed. It suggests that the Great Filter is still ahead of us, a final, terrible barrier that no civilization, or almost none, has ever survived. It is a test of our own making, the challenge of managing our own technology, our own tribalism, and our own planet. In this view, the silence of space is the sound of a cosmic graveyard, a collection of tombstones for countless civilizations that reached the exact point we are at now and failed. It is a profound and urgent warning. The third path is perhaps the most terrifying. It tells us that we are not alone, but that we should wish we were. The dark forest hypothesis suggests that the silence is a deliberate strategy, a product of universal fear in a predatory cosmos. In this view, the silence is a warning to stay quiet, to hide, and that our century of broadcasting our existence into the void has been an act of spectacular, childish recklessness. We do not know which of these paths is the true one, but the Great Filter hypothesis teaches us one crucial lesson. The silence of the universe is not a neutral fact. The absence of evidence is, in this case, a profound piece of evidence in itself. It tells us that there is something fundamentally dangerous and difficult about the transition from a planet-bound species to a star-faring one. It tells us that we cannot be complacent about our own survival. The Great Filter isn't just a hypothesis about aliens, it is a mirror held up to ourselves. It forces us to look at our own civilization with a critical, cosmic perspective. It asks us to consider our nuclear arsenals, our changing climate, our rapid development of artificial intelligence, and to see them not just as near-term political or social challenges, but as potential answers to the Fermi Paradox. We are, right now, living through what might be our own Great Filter. The search for extraterrestrial intelligence, which began as a quest to find others, ultimately leads us back to a profound examination of ourselves. The silence of the stars does not give us an answer, but it poses the most important question we could ever ask. Do we have what it takes to be a successful civilization? Do we possess the wisdom, the foresight, and the unity to navigate the immense technological and existential challenges that lie ahead? The universe is not shouting warnings at us, but its silence is the most powerful message we could ever receive. The future is not yet written, and the final chapter of humanity's story may be the one that finally answers Fermi's question. If you want to explore more hypotheses that challenge our understanding of the universe and our place in it, subscribe to The Archivist and click the bell so you never miss a file.